friends, this video on triangles part 18 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 17. Now we'll discuss criteria for similarity of a triangle. Two triangles ABC and DEF, as you can see, are similar if angle A is equal to angle D, that is, this is equal to this angle. B is equal to angle E, this angle is equal to this angle, and angle C is equal to angle F, angle C is equal to angle F, or AB by DE is equal to BC by EF is equal to CA by FD. This, if this is X, this is Y, this is Z, this is X dash, this is Y dash, this is Z dash, then X by X dash has to be equal to Y by Y dash, and this has to be equal to Z by Z dash. If any of this condition is true, either one or this, then two triangles are said to be similar. Please make a note. If either all the angles are equal, if angle A is equal to D, B is equal to E, C is equal to F, or if the sides are proportional, that is X by X dash is equal to Y by Y dash is equal to Z by Z dash, then two triangles are said to be similar. To define that, to say that two triangles are similar, we use this symbol. If you use this symbol, that means triangle ABC is similar to triangle DEF. To say is congruent to, we use this symbol. When I say ABC is incongruent to DEF triangle, that means both are exactly same. Length is same, angle is same, everything is same. Both are exactly similar in shape and size. Size is same, shape is same. When you say similar, the shape is same but the size is not same. Let's do some activity here. Let's draw this line and let's draw a particular angle. Let's suppose this is 40. Now let's draw one more angle, fixed angle. Let's suppose this is 45. Similarly, let's draw a bigger triangle here, bigger line here. Now, since this was 40, let's draw a 40 degree here. And from this point, let's draw again 45 degree here. You got this triangle. Let's suppose this is ABC, and let's suppose this is A dash, B dash, C dash. Then we can say that ABC is similar to A dash, B dash, C dash. Why? If you see, this angle is equal to this angle is equal to this angle. Intentionally we have developed. This is 40, this is 45, total is 85, this has to be 95. Similarly in this is 40, this is 45, this has to be 95. So if you see, angle A is equal to angle A dash, angle B is equal to angle B dash, and angle C is equal to angle C dash, correct? So both the triangles are similar. Now if you find the length of this, let's suppose this is X, this is Y, and this is Z, this is X dash, this is Y dash, this is Z dash. If you find the length on the paper, because this is the activity, you have actually drawn this, and if you observe, if you find the value of X by X dash and Y by Y dash and Z by Z dash, you will find that all are equal. That is, X by X dash is equal to Y by Y dash, sorry, Y by Y dash is equal to Z by Z dash. This is something which you will observe. So here what we have done, on paper we have drawn this. We have drawn this using pencil. We have drawn this line, and then we have drawn this fixed angle 40 degree and 45 degree. It met at this point. In second case, we took a bigger line. Again, we took 40 and 45 degree. It met at this point. And then we observe that angle A is equal to angle A dash, B is equal to B dash, C is equal to C dash, And then we have observed that x by x dash, the length we calculated actually using the ruler, and y by y dash and z by z dash all were same. This was the activity to prove that if all the angles are same, right, in both the triangles, they are similar. So we have this theorem, angle theorem. The theorem says in two triangles, the corresponding angles are equal. That is, angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F, and suppose. Then the sides are in similar ratio, that is, they are proportional, and hence they are similar. To prove that, what we'll do, let's cut this side D at this point P and at point Q such a way that angle ABC is congruent to angle DPQ. That is, this is X, this is also X, DP. This is Y, this is also Y. Exactly same. Now if you observe, since triangle ABC is congruent actual to triangle DPQ, so I can say that angle B is equal to angle P, correct? And angle C is equal to angle Q. Why? They are exactly same, they are congruent. Actually, if you see this triangle and this triangle, if you see, both are same, exactly same. I'll draw a big circle in both the triangles to show that both are exactly same. Now, since if you see that angle B was equal to angle C, it was already given, and now we have told that angle B is equal to angle P, so we can say that angle P is equal to angle E. If angle P is equal to angle E, that implies PQ is parallel to EF, correct? If PQ is parallel to EF now, using the parallel theorem, the parallel line theorem, I can say that dP by PE is equal to dQ by QF. Right? Or I can say that PE by I'm just taking the reciprocal by dP is equal to QF by PQ. I'll add one both sides. I'll tell you why I'm doing it. So this becomes, I'll get PE plus PD by PD is equal to FQ plus QD by QD, or I get PE plus PD is ED actually, or I can say DE by PD is equal to, this becomes DF actually, DF by FQ. Why I am doing this? Because I am to prove that AB by DE, right, is equal to AC by DF. Now I know that AB is equal to PD. I know this. AB is equal to PD and AC is equal to DQ. This is DQ also. DQ. I know this. So instead of PD and DQ, I will put those values. This becomes DE. Sorry, this is DE by, instead of PD, I will say AB is equal to, here DF, instead of DF, I will say, sorry, this is DQ, DF, sorry, DF, and this is DE. This is DF, and instead of DQ, I will say AC. So if I say this way, if you see now, DE, this by AB is equal to DF, this side by AC. That means both sides are proportional. sides are proportional. Similarly, I can do for this side also. Similar way, I can just draw a line parallel to this and I can prove this. So what I'm trying to do here is, I have proved that the sides are proportional. To prove sides are proportional, I have drawn this triangle, smaller triangle, which is exactly congruent to ABC. And then I proved that the line which I drew to create this triangle was actually parallel to EF. Once I got this line parallel to EF, I can use the parallel theorem to prove that this side dP by P is equal to dQ by Q. Or directly also I could have told that dP by dE is equal to dQ by dF. But I use a normal basic theorem. I added plus 1 both sides because I wanted to prove that this side, that is this x, by bigger side dE is equal to y or dQ by dA. And that's what I am. Similar to AAA, we have AA. Why it is true that if two angles of one triangle are equal to two angles of another triangle, then the third angle also has to be equal. See, I'll draw a triangle here, and this triangle is one triangle, and this is a bigger triangle actually. So this is a bigger triangle, right? This is A, B, C, and this is A dash, B dash, and C dash. So I'm told that B is equal to B dash, and C is equal to C dash. And obviously A should be equal to A dash. Why? Because if this is X, this is Y, this will be 180 minus X plus Y. If this is X, this is Y, because B is equal to B dash, C is equal to C dash, this also has to be 180 minus X plus Y. So if you see this value and this value also, so angle A will always be equal to A dash. So if I can just prove that if two angles of triangle 1 is equal to angle 2, then both the triangles are similar. We need not prove for the third one because third one is also by default taken care. Let's take some example of similarity of the triangle. You have to prove that if diagonals of a quadrilateral divide each other proportionally, then it is a. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.